Hello everyone, welcome to this session on building a brain-computer interface application using .NET MAUI. Today, I will walk you through how we can simulate a brain signal data, visualizing it, and build a cross-platform application for mobile and desktop application, and all that without a real PCI hardware. And we will continue in how we can modify it or extend it to actually connect with a real device like emotive devices, heads and headsets. Okay, so the agenda for of the presentation that we will start with an introduction to the brain-computer interface, or the PCI, and then we go for the .NET MAUI, like a quick brief about the .NET MAUI and what it is and why we're choosing the MAUI as an application. Then followed by a technical overview, including architecture and components. We will provide a guidance on how we can set up and start the development environment and implement the core features before showing the code examples and some of the best practices. And finally, we present the demo application and we will discuss the additional resources and discuss in detail this demo application. Okay, so understanding the foundational concepts of the brain-computer interface and .NET MAUI is very crucial for building effective application. We will explore what is the PCI, the brain-computer interface, then how .NET MAUI works, and the advantage of using it in brain-computer interface for cross-platforming applications. So, what is the PCI? Okay, so let me introduce what actually the main core idea of the brain-computer interface. First of all, our body have what is called bioelectrophysiological signals come from different systems and organs. For example, that we have electromyogram or EMG, which actually the electrical activity of the muscle. So if we need to record the muscle electrical activity, we have a device that's called electromyograph, which capture and record the electrical activity of the muscle. We have another device, it's called EOG, or electrooclograph, which actually capture the electrical signals of the muscles, which actually control the eyeball. And this is very important in measuring some of the clinical manifestation of some diseases. The most known thing in the bioelectrophysiological signal is the ECG, or EKG, which is the electrocardiogram, and this is measuring or recording the electrical activity of the heart muscle. This is waveform known for the medical diagnosis for a lot of heart disease, and it's very important to when you gonna to investigate any related diseases to the heart, you should have these records, and the waveform and have a different combination for different diseases, and it have its normal or the normal shape, which can actually you can capture it and know that the heart is normal or have or malfunction or have a disease. Then we have the EEG, which is electroencephalogram. This is very important because it's capturing the brain activity. When the brain do functioning, or for example, cognitive function, or if you move your hand or leg or something like that, this will induce some of the electrical activities inside the brain, because actually the brain is the main building unit is the neurons, and the neurons firing electrical signals across its like functioning. And there is a neural network inside your brain with a lot of like physiological and anatomical things that every part of the brain have its own like own activity or functioning can do it. In simple words, we can the any function from the brain, it will have like a certain pattern of electrical signals, and we put different electrode in the across the calf or the head to capture these electrical signals, and for each position, and sometimes we can relate different positions with each other to have interpretation of what actually the brain is functioning on. There are a lot of things. If you are like interested in such thing, you will find a lot of tutorials and a lot of videos online and a lot of materials which explain actually different topics related to the neuroscience or computation neuroscience even. Okay. So the brain-computer interface comes from how we are measuring the electrical signal from the brain using the EEG, and then we find the patterns of some of the functionalities. So we push that, or the brain-computer interface allow the direct communication between the brain and any external device. So we're capturing these electrical signals from the brain, and we do some of the signal processing on it, and we begin to start to interpret actually what is the functioning, and then we can make use of this pattern recognition of these signals. As I said, for example, that you can you control external device, any electronic device, or even a robotic platform, or you can interact with softwares using your brainwave. So in real life, the PCR, the brain-computer interface, involve complex signal processing, but yeah, the developers and learners simulate some of the data to test some of the algorithms or models, or like, for example, machine learning models or AI models on top of that to try to grasp and to identify or to predict what is the functionality now the brain doing, and try to trigger or like to integrate with another system or external system. So using the user interface or user experience application, so we can provide such thing. Okay, so next, what is actually that .NET MAUI? .NET MAUI is a multi-platform app UI, and is a cross-platform framework for building native application for iOS, Android, and macOS, and Windows. Till now, or to the present of recording this video, still MAUI do not support Linux applications, or like, for example, embedded Linux. But there is a lot of platforms and other frameworks that can support that. For example, ONO. It's one of the platform on top of like the same concept of MAUI, which supports C# and .NET, and it's a cross-platforming over a lot of things. It support the iOS, Android, macOS, Windows, Linux, and also WebAssembly, so it can go for web. So in MAUI, it's actually simplified the development activities and process to enhance the productivity of the developers. So you have a single framework for cross-platform. So you code once, and then you ship or produce your product for different platforms or like different devices. Okay, so using .NET MAUI for BCI applications allow developers actually to create responsive and interactive user interfaces across multi-platforming. multi-platforms efficiently. And this gives the MAUI capabilities to ensure the consistent experience regardless of whatever the operating system on that device. So, BCI technology has a wide range of applications, from rehabilitation for individuals with disabilities to even to enhancing the game experience. Even sometimes we see it like in simulation or training practices. So to understand this use case can inspire new ideas for your own projects. In this section, we will delve into a technical aspects of the BCI application, discussing the architecture, the essential components of any PCI application, and how .NET MAUI in the cross-platforming capabilities can be utilized effectively. So, a typical PCI application consists of multiple layers, including data acquisition, which you capture the electrical signals, or the signals and waveforms from the EEG. Then do signal processing, whatever it's like filtering and modifying some of waveform or transforming it to another domain, for example, frequency, like if you need, like, for example, power spectra or something like that, so you're going to transform it to a Fourier domain, or even you can, like, you do like invariant or multivariate analysis or principal components. So this is like a dimensional reduction for the signal to interpret some of the features of the signal and begin to interpret what actually the function is. Sometimes the signal processing, after this step, maybe you can have like a machine learning model or AI model, whatever the model they have, to predict or to assume to interpret the what the function was going to actually the print doing to induce it in the application itself. For example, if you you control the a game character in a game, so you will process this signal come from the EEG to identify which what the player actually, or the human which is place the headset on it, what it's thinking on, like, for example, moving the character right or left, or like do triggering for, like, for example, the first shoot gaming, you trigger like firing or something like that. So yeah, and for sure the other component will going to be the user interface of this application. And yeah, so for sure, understanding this architecture is very essential for successful implementation of such PCI applications. There are three key components of the PCI application, as we talked in the previous slide, which is the data acquisition and the print signals are capturing, and then the processing, or where the signal are analyzed or interpreted, then visualized. You can even visualize the signal to know what actually, even in such a research environment, you need like to see the whole for each electrode, the signals, and to see actually what is recording. And this is you have like a data visualization layer on top of your UI to display such signals or graph. So, MAUI allows developers to write code once and deploy it in multiple platforms, as I said. And this is very ideal for PCI applications. So you are focusing about the core implementation of your application, and you do not like care and how you will going to then modify it for different devices. So you will going to code once and ship it for different devices. So let's start. So now that we have a sound understanding of the PCI in .NET MAUI in the top of our general things, so we will guide through the initial steps to developing, like for example, setting up the developing environment and ready for the building your first PCI application. Okay, to get started, we need to set up our developing environment, which is .NET. So we will going to use the Visual Studio, and we will use the MAUI workload. So you should install that, and there is a lot of tutorials and a lot of videos or online materials that guide you to how to set up things. Such as that in a lot of like, for example, like videos or a reading tutorial, so you can have a lot of resources and material and how to do so. For a real application, you will need another SDKs or essential tools, which will maybe necessary during your development of the application. For example, if you have whatever the headset you have, you will have like an SDK or API, application programming interface, which will let you to have the capability to control the headset and to communicate with it and to capture what data come from the headset itself. So you must target and know what the SDK and API supporting this headset and utilizing. There are other tools which can be used. For example, if you need for signal processing or do machine learning or modeling, so you will have some sort of different tools. You will utilize it to deploy or to develop such things. For example, the most common tools, it's called MNE or MNE. It's in a Python framework which give you the ability to do a lot of EEG processing, whatever the signal processing, or even advanced functionality on the signal processing related to EEG. So maybe you can have another interaction, not just .NET. Maybe you can have a backend service which is developed by Python for a certain action or for a certain single use, for example, signal processing or advanced functionality, and you can communicate with it. So you have you should know that there is maybe other tools you are going to be utilized during your development of the PCI applications. So you must feel free and not oriented for a single tool. You must have to utilize different tools to meet your goals and to achieve it and to develop the PCI application. So you must be flexible on how you utilize these tools and SDKs. Okay, so we will for understanding the basic structure of the .NET MAUI project. This will help you to navigate your application effectively, and you will know how you will going to develop the application on top of the .NET MAUI. So we will discuss the folders, the files, are in the project structure of the .NET MAUI, and how you will going to change and to tweak things to make the application work as you intend to diffuse. So yeah. And here come our application. So our application, we will call it BCI Mock App, because actually it's a mocking app or simulating app. It's not connected to a real device. I don't have a headset here, so I don't have to connect with a real headset. But I will go with you how you can, for example, connect with emotive devices. That's thanks for the API and SDK, which is already you can find it online, and you can read the documentation, and you know how you can get things to be done. And I will show you some good snippets on how you, for example, connect to the for the headsets. So our application, we're going to simulate the PCI environment, which connecting to a MOOC device and then generating synthetic brainwave signals like delta, theta, alpha, and beta. By the way, Emotive do not provide the delta wave. Delta wave, it's the low frequency waves on the PCI in the EEG frequency band. So it's in the medical or clinical investigation, sometimes it's very crucial to know it. But for example, in the brain-computer interface, it's rarely you will going to like make use of the delta wave. But I will show you that we can see the delta, theta, alpha, and beta, and the red and gamma, which is the high frequency. Sometimes it's very useful if your application were going to like to target, for example, epilepsy or something like that. It's very crucial to have the gamma waves and to analyze it, because actually it's a very crucial for epilepsy applications if you need like for identification of the epilepsy episodes or something like that. I will not dig deep in that because it's need like a lot of time to explaining. Yeah, but for our application, we will like focus on delta, theta, alpha, beta, which is synthetically generated from the application, and visualize. And then we will take this and the power of these patterns to visualize the concentration levels of different mental states. Okay, so our application will start from, for example, that when the user we're going to tap a connect. This connect will going to mimic how the real PCI will going to connect to the device. According to the headset, it's have a maybe different way of connectivity. For example, in Emotive, you will need like to scan first and to define the headset and to get the headset IDs, and then using your authentication for the Cortex server, so which is the core SDK and API, and then you will authenticate and connect to this service, and then you can consume the API to get the data from the headset. For example, OpenPCI, it have its own API and SDK, and it have like connectivity using different type. For example, you can connect both like Emotive or OpenPCI or maybe NeuroCity devices using Bluetooth or Wi-Fi. So you have such things and such abilities. So you need to know that when you will going to develop a real PCI application, you will need like to communicate with the headset using different protocol, whatever the Wi-Fi or Bluetooth, and then you do the connection according to the API SDK and how the communication is done. Using authentication first, then connection, or connection, then authentication. There is a lot of variety that depended on the manufacturer itself. After the connection, we will have the ability to show the status. For example, the signal qualities, the battery level, the connectivity status, and all of that. This is useful to simulate a real-world app behavior, even if there is no device is available. Then we will going to implement the data streaming, which is actually a synthetic generation of waves. So we will like simulate how we can capture data, and it is very essential for real-time applications. And we will cover how to set up the data streaming from PCI devices and handle incoming data efficiently. So how we can handle this data and showing it in the user interface. So, when we are talking about .NET MAUI, so we have a certain design pattern which is adopted. This design pattern is the MVVM, which is the model view and view model pattern. So, for example, that we have a service, we call it a PCI service. We will going to name it such way, which is the generating the data. Then we have the main view model, which handles the logic and the states. Um, so then the UI, which will be built because .NET MAUI is depending on XAML, extending markup language, which binds the view model with the UI. So you have and this a clean separation, which makes the app very scalable and maintainable over the time. So the maintainability and the scalability is assured with such design pattern. Okay, so delta, theta, alpha, beta waves will going to be shown as a progress bar in the application, and this will form associated with the different brain states like sleep, relaxation, focus, concentration, and such things. And these are the key to user feedback. So you will going to see the progress bar, and we will simulate these patterns of the waves, and we will detect and try to detect according to the power bands of these waves to predict what is the mental state now. If it's in concentration level, if it's a relax or focus or something like that. Okay, so there will be a concentration level. This is also on a progress bar. Would be calculated using ratio between the beta and to alpha waves, and this is like a simplified model to actually to capture the concentration level. But yeah, but it gives the user clear visual cue about how the actually when it goes this state, how the concentration level or how this mental state level achieved. So we will simulate how the mental state feedback could look in a real app. Buttons like meditation, focus, distraction will going to be simulated. Like for example, you will induce the simulation for such stage, and you will see the change in UI and how you will going to interpret in which actual state is it. So this helps in testing how the app behaves under different cognitive conditions. Okay, to ensure PCI to ensure that PCI application adhere with the best practice is very crucial and vital, and that we will like consider some of regarding through like performance, platform compatibility, and error handling, user experience, and even security. For example, the performance is very crucial in PCI application, and this is to achieve a real-time interaction, and this is very important. And for example, implantable devices, it's have like another wave you should consider in the performance consideration in the amount of data. So sometimes you will need to implement some of the compression algorithms on the signals because you have a lot of data come through this sort of devices. So yeah, real-time application, you will be very careful and focused about the performance. So you need like to select actually the programming language that we're really going to achieve such performance. And you will need a various strategies to optimize this performance in time, memory, and all of that, including efficient data handling and even when you are doing the data processing. So when we develop the cross-platform application, there are unique challenges to address. .NET MAUI actually, give you the flexibility because it designed to run in across different devices, for example, Android, iOS, and Windows, Mac OS, even Tizen. And it to use platform specific configuration and manifestations or manifests to ensure native behavior across all devices. So the look and feel of the application on different device, it will be native behavior or native appearance on the device itself. Robust error handling is very important, and to maintain smooth user experiences, PCI application. this is very important. Whatever the error handling is, and the error yeah, maybe panic recovering or something like that should be considered. This is actually a general best practice for any developing application, but yeah, in real-time applications, you need like to be focused and clear about it. So user experience, it's another vital rule for success of the brain-computer interface. You need like very simple. So if we getting into the following principles, so you will stick to solid and KISS, which is keep it simple and straightforward. So yeah, you should do that, and you should do the UI in very simplistic way. You do not need complex things, because actually you do not need the user to engage in high level of cognitive interaction during actually you need like to capture things from him, so you need like to be focused, not to be distracted from a lot of things. So the UI should be very simple. Okay, so now we will go into the demo application. We will first a couple of slides, and then we go for actually how we were going to develop such application. So here we just like need to illustrate the concept and discuss the demo application, which is the simple Mock app. And this application will serve as like a practical demonstration and techniques to learn, to see how we can develop such a thing. Our demo application, as I said, it's monitoring the brainwave activity in real time, and then do like we were going to walk through the features, focusing on how it's capturing and display the data for the PCI devices, which is a Mock device. The demo application is also include a feature to display the user concentration level with some sort of images on that this is like in focus, or relax, or in distraction, or highly focused. So we will explain how this functionality is implemented. Finally, we will showcase example on how to deploy the demo application across different platforms. For now, I will show you the Windows desktop app and Android on the Android emulator. So we'll demonstrate the power of .NET MAUI in creating versatile PCI application across different devices. Okay, so binding the user interface element with data stream is essential in such applications like real-time or PCI real-time applications. And in our demo, we will show you how this binding actually come in the top from the model view to from the view to model view. Yeah, this is a pattern, and we talked about it. This is the design pattern. Actually, we will take care of it. We will like this approach. Like the app is structured in a service generates the data, model will handle the logic and data, and then the UI built in XAML, which bind with the view model. And this is a clean, as I've said, there is a clean separation between the different layers of the application to maintain the scalability and extension and further extension. Okay, so let's start with the thing here, with the demo. Okay, so as you see here, we were going to create a new project, and I use the .NET MAUI. If you saw, for example, I also have like ONO platform, like if we need like to extend that for Linux applications, but we are focusing in .NET MAUI. If you didn't like find this, like because I have a recent project templates, you can find here all the templates. But if you need like to find it, like just like type in MAUI, and then you will find the workload that you needed, and yeah, start .NET MAUI app, then push next. So here we will rename our project. We will name it as BCI Mock App. Yeah, Okay, this and let me change this folder directory. We can, like, for example, dev have, yeah. This will be the solutioning, which is the BCI Mock App. Okay. And next. Then you will need, like, to select the framework, actually the which is .NET version. So this .NET 8 is a long-term support, and .NET is the most recent framework now, which covers all things. So we will choose the most recent framework. Just have the fix and all the patches of the previous .NET framework. Then we will going to create. So now Visual Studio is creating our project, like the scaffolds and the templates of the .NET MAUI applications. And as you see now, we have the PCI Mock application, and then there is a sort of different folder structures. For example, that we have here the app XAML, and if we like expanding, you will find that app.xaml.cs. This is define the global resources like the themes, styles, converters, and all of that. And all the application lifecycle. So if we like opening it, so you found that is the resources or define the global resources. And if you open the C#, this is how actually you will going to initialize the component, and you can extend different things there. Then we have the app shell .xaml, and if we extend it, you will find that the C#, and this is defines the visual structure of the navigation, the shell-based UI containers. If we open it, so you found that the content which is going to be distributed across the different platform. And here is the C#, and this is how we can install the app shell. Then we have the configuration of the or the MAUI program, the configuration or the dependency injection, and the app-wide services. So as here you see that we how here we can configure the fonts that will be utilized by the UI, and this is come from the under the resources. You will find the fonts there. So if you need like to extend, if you need like to replace or add new fonts in your application, so you will add it here, and then you will define it and configure it in the main program. Then we have the main page XAML, which is the actually your UI is start from here. This is the main page. You can extend it with different pages that depending on your design of the application. This is how you actually, for example, in this scaffold or the initial creation of the project, it gives you like a demo application. So this is like if for example let's us run it. We will going to run it on Android emulator. Actually, the demo application is just like application with a button, and this button is like when you click it, it's like counting all of things. By the way, this is the application that we're going to build. Yeah. By the way, let me clean this. Actually, I need like to clean it. Let's start like as we start from initial point. So I will close this. and then go for the um, emulators, yeah, and go for the device manager. So we're going to open the device manager. I'm going to delete that, stop it, and maybe like delete it. Close it. So I will going to delete this. And let's create a new one. So if you, for example, why I do that, because if you, for example, if you need to start from the beginning, so it will going to ask you about to add like an emulator. This is installed with the Visual Studio. When you are installing it, you will install the Android emulator in the Google supported emulator. By the way, you should also enable the hypervisor or the virtualization in your device to ensure that the Android device manager is working fine. We will create a new one. You can select, but this is the normal. You can select the whatever the API or the Android OS version, so you can identify that. So we'll go for defaults now. This will create a new one. So actually, if we run the initial application from MAUI, will be started on the emulator. Yeah, this is the initial start, so it will take time. It simulates that the Android is like starting or putting up. Yeah, while it's open, let's continue. Actually, here the platform, which you define the different devices that can support it throughout MAUI. So you have in the Android the manifestation file and all that thing. And during the compilation, the building of the project, it will actually define all these things for you for the Android and OS. So you are just like a coding. Maybe you need like sometimes to change some sort of like, for example, how the Android will going to show, for example, the splash screen and all of that. So you need like some tweaking. But yeah, but you can do all this from outside. Like maybe you not like to touch things like that, but in some application you will need to go further for each device or platform that you supported. Yeah, so this is the platform, and inside it, each folder have the supported device. We have the resources, which is here the app icon. So we will need, like in our application, we will need to change the app icon. I will show you now if it's open. Yes, still it's open. There is like a default app icon, which is .NET application, and there is like a default splash screen. Also, maybe you need like to change that. There is like here the role folder. If you have like some text or something is raw or some binaries, you can actually put it here. Here the images, here the resources of the images that you will need to utilize it. In our application, we're going to add some images that it will be utilized. And here these styles, for example, the cars and all of that. So it's to define the color palettes which will going to be used in your application, and here the styles and all of that. This actually all of that is defined under XAML. Yeah, for sure. Angle brackets is is it drives the internet now today, and even some sort of mobile application. Yeah, let's start. Yeah, finding this device should. Yeah, as you see here, we have the icon, which is the app icon defined here, .NET, and it will going to start the application now for us. Yeah, it takes some time to boot up your application, especially if it's the first time you push then it will attach the debugger to it. As you see, now the debuggers have been attached. Now we see the splash screen. Okay. Here our splash screen, which is defined here using this SV folder and the SVG file under the splash folder. Yeah, it's very slow. Okay, so yeah, so this is our application in the like the main scaffold or main and the when you create the MAUI project, you will have this kind of application. So if we are like clicking, this is like a counter, and as we see here, this comes from the main page. .cs, which defines the this method or function that is on counter clicked. So when the button is clicked, it will going to count and show how many times you counted. So this is a simple application. Let's build our application. So to build our application, we need like to define some sorts of how actually our application will going to work. So first thing, how our BCI Mock App data flow. The user we're going to trigger an action. This action through the view, like in the command, which is the like connect to the device, and then the command is going through the view model, and through a service that we were going to create to handle the data event and create a data event, and then interact with the view model and to have a property update on the view, which show us our synthetic data, and the actions come from the synthetic data, which is the concentration level. So the user will plus connect main view model we call the model PCI service. The service will emit the signal data every 250 milliseconds, and that simulates the data generation. And then view model updates the properties, like for example the alpha values, beta values, delta values, and all of that. And the UI auto updates via the data binding. So for example, our data generation, let's go for so the data generation. We have the Mock PCI service, and this is actually the service itself. Like that. So if we need to draw things, so this is a service which we call it the MOOC BCI service. It's have like a timer with like 250 millisecond, and then there is the event handling system. Okay. This timer we're going to generate the MOOC PCI data or PCI signals, which is the brainwave values, concentration level, and also the device status. Then the event system is going to publish the publish the data via events. Okay. This event, we will call it on data received. So you'll see it. And on connect, this connection changed. This is a status of the connection. Okay, so this is, for example, this on data received, this is like the brainwave. And the derived value, which is the concentration levels. And here in connection change, we're going to give us the device status of the connection, status, battery level of the headset, okay? Not the battery of the mobile or the device. So it's a headset battery level, and the signal quality. Okay. So then we have the second layer, which is the business level or business logic of our application, which will be defined inside the main view model. Okay. So the service will initiate the events, and it will go through the main view model, which are going to update what? Update the properties and update UI states. Okay, the user interface states. Yeah, and here's come our third layer, which is user interface. Which will be defined on the main page, XAML, and also the CS, the C#. So the UI will going to bind to view model properties. So that is actually maybe the diagram, the plug diagram are going to be the main view model. Have a properties, command, and then go for the main page, which is the UI. Have a data binding to ensure that the data will going to change the UI states and the user interaction actually when the user push connect or push different buttons for simulation of the different mind states. Then we have the simulation, okay, simulation scenarios. Take user interactions. That, as I said, that he will push for different simulation of different mental states. For example, focus, concentration, or distraction. Then it will take this user interface interactions through the model view. Oh, sorry, for view model, the main view model. Sorry, maybe my my handwriting is not like that good, but yeah, I hope that is clear. Yeah, the mock PCI service, which do the simulation scenario for us. Actually, the MOOC PCI service, you can extend it a lot of things. You can put, like, for example, in a real device connection, you will going to have all the connection logic would going to be in the service. So yeah, you have like a service which interact with the main model view model for like it would trigger in the events, and then the model will handling the binding and the binding on the user interface, and how it's going to update or change the properties of the UI. And this is how actually when the simulation button is pressed, any button of them, the view model will going to call the corresponding scenario or simulation scenario from the service method, and then the service will override the normal data generation with the scenario of a specific pattern to ensure that the UI is updated with that through the main view model. And after the scenario complete, the normal data generation will going to resume. So it's like pausing the synthetic data generation in the normal it's a thing, and you like simulating that the person or the subject is under a certain mental state for a period of while, and then it will return back to the normal thing. So the data processing logic, actually how the computation level will going to be calculated through our application. So the data processing logic is like, for example, it's calculated based on the ratio of the beta to alpha wave. So if we can like build our formulation or mathematical formula for it, so this is our concentration level. We have the beta value. Okay, this is the power. Actually, in emotive, it gives you the power for each band, so you can subscribe for this data, and you will get it. So if you have like the beta value over the alpha value, the alpha value. So this ratio, it will give you the concentration level. But actually, to be right, so we need like to add 0.1, and then we can subtract 0.5. This is like putting padding level shift. Okay, then like centering it. Okay. Yeah, to ensure that the level is like maintained in the progress board. So the values is to simulate the focus concentration with increasing in the beta activity relative to the alpha activity in the real PCI application. So this is the overall what we are going to implement it. So let's start to implement it. Okay. So let's start with, as we see here, we have like for example, this icon. We need like to change it. Like for example, this one. So we need like to change the app icons. We need like to, by the way, we need like to change the splash screens, almost that. So I prepared some of the. By the way, all of this code is under the GitHub, so you can run it from you can clone it and then run it. But we are here building step by step. So here the app icon is defined with SVG. Already I have been saying change it to have like my own SVG rather than .NET. This is the app icon, and then also the configuration of the app icon configuration, all the weights, all those things. So here, like we have the brain icon, the brain connection lines, and PCI text. This will be shown as our icons. Okay. Then I changes the splash screen icon, and then the color palettes also I change it. Yeah, this is splash screen. So I'm here because actually our time is like very limited, and we need like to cover all things. So I'm doing like copying and pasting from the pre-prepared project I pulled in. You will find it in the GitHub, the link on the in the slides. I will share also the slides on the GitHub, and this recording video also will going to be on YouTube, and you can access it from the GitHub. Okay, so this one, and yeah, let's change some of our styles, which in the car, because I changed the car palette, so I copy it. So we will open here in the styles, colors. So this is like the signal core, which is the ranges of the progress bar, the PCI wave colors. I defined the delta waves, theta wave. Let me also the delta, theta, alpha, beta wave, and the connection level. These are the colors that we will going to use inside our UI. Then the theme where process it's regarding, because actually I do like dark theme and light theme, and we have like signal brushes, which is the focuses levels, and then the PCI wave brushes, which is defined in the colors and how the progress bar were going to be changed. Let me also ensure that. Okay, there is some resources or images while doing copy and paste. Actually, I prepared these images through some co-piloting. Oh, sorry. So this is the old project. So I will take the resources from it. Actually, the image sources. So I need that, and that. Okay, so let's back to dev tutorial and put our resources here. So the images and put our resources there. Okay, these resources. So here is the concentrated phase, focus phase, neutral, and relaxes. These are our mental states that we are simulating. And some icons for the like dark theme or light theme. Okay. Then we will go for the AppXAML, ensuring that all the resources are defined. Which is defined that the class, the BCI Mock App, and also ensures that this is the namespace and some resources like the cars and styles and all of that. Also, you need like to ensure that the styles is cascaded across our UI. Okay, and then return back to the app demo. Okay. Then we like have the apply the themes, because this, as I said, that I'm doing the dark theme, light theme, so I need to update this. The updating is happening here. We set the initial theme, so is a light theme or not. Like if the user put the icon of the light or dark theme, it will going to change the themes. Then we putting the sum of the methods that we're going to handle how it's we're going to apply the theme or the switching between the light and dark themes. Okay. Yeah. Then go to the app shell. Yeah, we didn't do anything with the app shell. Actually, we didn't change the XAML, and the initialization component of the app shell is not like touched. Yeah. Okay, so in our UI, this is our main UI. So we will change the UI because we need to implement our UI. And here is our UI. So we define the device status sections that is containing the connection status, the pattern level, the signal quality, and we have the brainwave activity section, which is the progress bar. As I said, that we were going to visualize the different frequency band of the brainwave, which is the delta, theta, alpha, and beta, is at a progress bar. And this way we define the progress bar, we define how it's going to bind with the data on the delta value, and this has come from our services and come from the model view. Yeah, the concentration level section, which contain our image or feedback on the mental state using the image, and the concentration level for it. Then we go for the simulation control section, which is the buttons that contain the mediation, focus, and distraction. These are three states that we can simulate it on our application. So all of that is defined in the UI. Then we will ensure the binding contexts have been updated through the UI. So we need like to change things. We need like to have the view models and to ensure that everything is come from the view model, which is handling the data generation events from the service. Okay, so now we need like to build, because actually there is a view models that we need like to implement it. So that's why it's the wiggly error things. Okay, we were going to create some of the folder. Let me minimize this to have a clean scene. Okay, so under the BCI, we're going to add a new folder. The folder we will call it as the models. Okay, inside the models, we have actually different couple of. Let me create the folder first. Models. Then we have services. Yeah, and we have the converters. This we're going to convert the values to map it on the UI. Converters. And okay, inside the models, here's come the two main the PCI device info and the PCI signal data. Okay, so let's create and add an item there, just in C# items. We call PCI device info. By the way, device is small here. Yeah. Um, this is the content of the device actually. So from models we have the device ID, the different different variables that we have. The device ID, device name is connected. It's like a boolean, true and false, and then with the battery level and signal quality. And then we define the PCI data, which is recite all the values and how we change them. Get set it, guardian set for sure. This is typical C sharp. PCI signal data. Okay, so this is our the signal data, which is the cloud defined the signal data. It's in 5 property changing, so it's a changing. This is how the data is binding, and then we define the different like the theta value, and we're going together and select it. And then the mental states, signal quality, concentration levels, all of the data generations. This is very important. The mental states, concentration, and the different frequencies band of the PCI of the brainwaves. Yeah. Okay, so let's do the converter. This is a value converter. This will convert the values to progress bar conversion. So it's like you map the progress levels with this converter. So we create here a new C sharp. So it's called value converters. So this is the initial convert. This is like the connection. Is it connected or not? They convert back, which is converting to values, and then there is like a progress bar converter, which is convert each value to the progress bar level. Then we have the services. This is the main PCI service, which all our generator or synthetic data has come from. Okay, still we didn't put the view model we were going to do after the services. So we will going to add a new item here, yeah, and then we will call it to mock PCI services, mock PCI service, and yeah. So quickly, this is the service, the PCI service, which define. This is the class which you define different methods inside it, and this method is how handling the data generation and how it will define this data. It defines the timer and ticker, which we're going to generate different random values, which is mapped to the alpha wave states, which has come from, for example, the delta 0.5 to 4 hertz and the beta from 13 to 30 hertz. So we do all these mathematical conversions to ensure that it's within the frequency ranges. And because we actually synthetic generation, so we do randomness value, generating the randomness value. Then simulate the signal quality, the concentration level is measured, and then mapped to the concentration level, which is the data, which is the emitting, defining the concentration levels, which come from the ratio that we discussed in the note section. Then we simulate the concentration scenario, which do, as we told, that it will going to pause the data generation, then generate a certain state, which define, however, it's a meditation or focus or distraction. And this is the initial time in generation, which, as I said, every 250 milliseconds it will generate this random data. Okay. So yeah. Okay, so then we need like to build our view model. Sorry. Okay, so this is our view models. Um, yeah, yeah, the view models. And then why it's bullet here? Yeah, this is right. Okay, inside the view model, we have the main view model, which defines the view model, which we're going to interact, do the data binding with the UI, the main page. Okay, so yeah, this is how we define our view model. Which will listen, will subscribe to the events, come from the services, and do the tweaking on the and do the data binding to the UI and changing the UI across the changing the property of the UI. And this has come from the typical interfaces that is how the toggling of simulating, the toggling of the push buttons in the simulation section, and then it will update the triggering the events from the simulation concentration scenario from the PCI services, and began to start and changing the properties and states in the UI. Sorry. Yeah. So. Okay, let's build and see if there is like any issues. Yeah, so now it's building up. Okay, so the building is done. We can run it on our device. First we will run Android, then we change it to Windows to see in a different device. This how is the beauty of the cross-platforming. As we see now, the icon changed, the app icon changes as intended, and it will start on our application, and we will see that it changes the splash screen. Yeah, now we see that splash screen has changed with the icons that we use. This is the brainwave, BCI brain computer interface. This icon, that pill. Yeah, let's start. The application we're going to start now. Here I'm starting. Okay, so it's in a break mode, yeah. So I need like to continue. Yeah. Okay, we didn't load the, yeah, we didn't load the service here. Okay, so, yeah. Yeah, we didn't load the service actually. Sorry, we should load our services here and yeah, like register our service, register our view model, register our pages, and register shell to ensure that all things are working as intended. So yeah. So yeah. So yeah, this our application is running now. So we can change the dark themes, dark modes, if the user need like I like dark modes, by the way. So yeah, and here when the user we're going to connect, it will going to simulate the device connection when connected, and yeah, the signal at the better level it shows. Then there is the random synthetic data generation for the brainwave activities, and here the concentration level it's yeah, it's shown here. For example, if we need like to simulate the meditation, as you see, that affect the concentration level, the meditation. Then if we like simulate the focus, now it's focused, high concentrated. This is the mental states. If we do the distraction, it's a random wacky thing, so it will not like have. So yeah. So now our application is working as intended. So this is our demo for how to build the PCI application in UI. Actually, let's go for how if there is a real headset with us, and how we can like change or tweaking some of the, like for example, we can put another service which handles the connectivity with the headset. Yeah, this is a type of things that you need like to interact and to get actual value from the API or SDK of the headset. So, before we translate to discussion and continue our presentation, yeah, let me close it and simulate it on Windows, like target on in another target for Windows machine, and then play. So with the same code base, we don't touch anything. We will have an application can run in different platform, different devices. So yeah, this is the beauty of cross-platforming application. MAUI, Ono, Qt, all the cross-platform flutters, all of these are very good. And yeah, so we have the same feel, unlike of the application. Also, it's responsive, as if we like, for example, put that, so it's responsive across whatever the size of the window. Then we simulate the connection. Here the connection have been done. It's the same simulation. We can meditate, can focus, and we can do the distraction. So every functionality of the application transit to can be run in Windows, can be run in iOS, Mac, and for sure Android. Okay, so let's switch to to complete our, for example, how we can utilize the real headset. So let me okay, so in this section we'll provide the practical like code example to illustrate like if you need like to as I said connect to a real device. The basic code snippets for device connection using the Emotive Cortex API, for example. This is a like example for emotive headsets. They have the SDK, the API, and also they have examples in different programming languages like Python, C#, and C++. And they implement in Qt. Okay, so this code illustrating the C# implementation for connecting the emotive PCI, and this how we can like build another like a service. This service we're going to be the PCI emotive. We will create a folder called PCI, then we can create this class in it. As we see that there is in this headset connector class, we have the method of the headset. Let me have like later band. This is the headset connector, and inside the headset connector, it will going to initialize the context client, which is come from the Cortex Access service, and then it's we're going to have a create like authorize or create like another objective which is headset finder, and all of that is from the Cortex SDK, and here how we're going to initiate the event handlers and initialize the configuration. And there is in the task there is a connection at the start to connect to the headset. By first it will going to scan to find the headset, given the device ID and using some configuration like the application client ID, and because you need like in emotive like to register first, register application, get your credential and authentication to then put it in the configuration.cs, and you can then run the SDK and actually get the APIs from the installed Cortex services. And you will find here how it will going to the connect using the async function to ensure that while this do the connection, you don't like lose any of other functionality from the UI. So you do the async thing. So this is like an example of the providing a solid foundation of how you implement and connect to the PCI. So this is a good snippet. Actually, there is other things like disconnection and all things can be continued, but you, as you see, this is like you can add it like a service and everything's done. For example, the data processing, it need like to be changed, as we said, that we do not have in emotive devices bring the delta wave band, so you need like to have some tweaking. By the way, but here how you can subscribe and capture the data after the connection through the data stream, and then you can define, for example, the subscribe for EEG data, for raw data, or even you for this specific our application, which is the mental states, you can subscribe for the power of the different brainwave band, and you will get for whatever for each electrode you will going to get the the band values, the power values of this band. This is the band power, and here this is the how the data stream will going after you subscribe for the EEG data stream. Okay, so so what next? Yeah, learning resources. So if you like, there is like you should like explore official documentation for the BCI EEG headsets manufacturer to gain solid understanding of their features, their functionality, what they support, whatever the SDKs and API and all of that. Also, there are the tutorials and guides on .NET MAUI. I'm leaving here the link to learn more about .NET MAUI. And there is tons of videos, tutorials, and online materials on this topic. Okay, community link. For what I know, it's the most like large community than OpenPCI. It says have a community forums and online forums. So you have a community engagement. So engage with the community. This will going to ensure that value for you. It will going to add value for you because actually it's to give you this how you can collaborate with other dev, with other researchers, and all of that to expand your knowledge and also maybe to find your solution for a problem or something like that. Online forums, Discords, whatever any social media, you can connect so you can have more engagement and knowledge. This is how you engage actually. Future developing. This application can be, as I said, that is to be linked with a real device, and you can expand it. You can expand the UI. You can maybe make it more, put some improvement or any sort of needed like to be improved. For example, you can after the mental state, you can, for example, add another page for like a gaming simulation or something like that to interact with the headset and the user, like to like do telekinesis things, and you can do a lot of things with the PCI. Neurotechnology is awesome. So in conclusion, the opportunity in PCI development. So the upcoming in the upcoming years, we will see a lot of brain-computer interface application. Already we see it, and we see it in some of the rehabilitations and research and some of the interaction with gaming, the fusion between the next state of the XR or AR, the augmented reality or extended reality with PCI is very futuristic and also is very promising and potential to utilize such application and to combine between them. This is actually Web 3.0 is not Web 3. Web 3.0 is like to extend the augmented reality, extended reality, brain-computer interface, other neural technologies, and you can have a lot of lighting future. Utilizing the .NET MAUI, we show you an example of how we can do that in .NET MAUI in a closed platform framework. So you can push your limits, and you can do what you need, and you can deploy it in whatever device you need it. In conclusion, that is, we're building the brain-computer interface application with .NET MAUI. We present exciting opportunities. With the right knowledge, tools, and practices, you can create impactful applications that harness the power of human brain. Thank you, and goodbye.